We've been working clearing landmines for over 20 years now, and one of the challenges we have is locating the actual landmine. Once we find them, they're relatively easy to destroy, but they're made of plastic, they have a very small amount of metal in them, and when they've been laid for 20, 30, 40 years, they're difficult to locate often. So what we want to do is look and work with the university and industry to see if there is a better way of locating landmines. Now, all of this came about through Sir Bobby Charlton and him visiting minefields in Bosnia and in Cambodia, and the minefield that he visited in Cambodia was a mag minefield.
There were some people that gave me a view of what it's like when a landmine goes off. And I mean, I was only 100 yards away, you know, and it frightened the life out of me when it exploded. And then they said, well, just imagine if a young boy or a young girl was walking past, you know, that somebody's actually left that mine solely to destroy them. And I did ask, you know, well, how long is this likely to go on, you know? And they said, well, it's almost forever. You know, to clear landmines would take up to 1,000 years if you try to clear the landmines that are in the ground now in various parts of the world. And I was on my way back from what we were doing there, and I'm thinking to myself, well, I've got you. There must be a better way. There must be a better way of actually approaching it. It can't possibly. You can't possibly wait. We have brainy people in this country. There must be someone that can think of a better way of doing it.
So when he got back to Manchester, he was looking at the contacts that he has at the University of Manchester and the University of Lancaster, and also Rapiscan, who are a global airport detection company, and us, the Mines Advisory Group, who do the work at the front end looking for the mines. And he brought them together in a loose consortium, really, to see if we could all work together to look at different ways of locating landmines. And through that, the knowledge transfer project came together.
It was really spun out of work that a company I'm associated with, OSI and Rapiscan Systems, who were involved in research with the Manchester University research teams, Bill Lionheart and Tony Payton. And it was a project that we were looking into passive scanners, the walk-through body scanners, and the technology that the guys had thought could help this project. So taking the research, we then, with the help of Bill and Tony and others in the university and the research teams, we thought the technology that they had in there could help us in this field.
The initial project, while we were still in the process of forming the charity, to translate some of the technology that we'd already developed for other applications to mine clearance, was funded by the KTA project. So this has enabled us to do some pilot studies where we've been able to explore some of the technology we're going to use, including metal detectors and combining metal detector data with some other methods such as ground penetrating radar to improve mine clearance. And those pilot projects have led to projects that are now funded by Findabetterway, so that we'll be able to deliver the technology that's actually able to help the mine.
Ideas were put on the table, and we'd still not formed the charity in full. But it gave us hope. There's a group of guys inside with Sir Bobby, and who really was the driver of this. He thought it could be done in a better way. And with the help of the Dean of the University, we took these ideas.
Under the Geneva Convention, the landmines should be laid with a detection ring in them, a metal ring that means that they're easy to detect. The idea wasn't that they would cause a humanitarian problem after the military conflict had moved on, but the reality is, in most cases, that the mines were not deployed with the location ring. So they're very, very difficult to detect.
For example, the type of objects we're talking about, this is a small anti-personnel mine, and this has purposely had an aluminium ring put around it to make it detectable. This ring is very detectable. It's quite a significant amount of metal, but it's also very easily removed from the mine itself. And then within the mine, These are components not from this device, but from a Type 72. This is a very low metal mine. There's typically a small amount of metal that's associated with the detonator components. And that's really what you're trying to distinguish from the metal detector, metal characterization side, and you're trying to distinguish those over more routine metal objects which might be found in the field as well. So that's part of the problem, and also the other part of the problem is then to associate those types of metal components with whether they're associated with an explosive charge, which is typically non-conducting dielectric in nature.
The University of Manchester has been fantastic.
The real reason he's doing polarisation.
They've all helped to pull it all together. We have so many intelligent, bright, and some of the professors and some of their accreditation is just unbelievable. They are so intelligent that, but they've volunteered. We have somehow or other got together, and we've been able to have the most brainy people in some of the most brainy people in the world.
I think the challenges are finding the skill base in the research teams. Massive challenge. They found them, by the way, but that is in itself a skill base in itself. And at the same time, to find a skill base that is interested, that is excited by our challenge of the project, that has been delivered inside the university. The guys and girls that are working on these projects in Manchester University are amazing. They are absolutely 100% dedicated.
You also need the expertise that allows you to process that information properly, which is why when we're involved with an organisation such as the University of Manchester, it enables us to balance the technical expertise along with the expertise from the mathematics department, which enables us to have like a full package of help that's required, rather than just going to one area, getting a particular bit of information, then having to pass it over. It's one-stop shop seems a bit of a trite phrase, but it is that level of if you can make contact to the university and they can then go off and provide all the expertise because they have expertise in such breadth in so many different disciplines.
Well, I think we've had substantial benefits from it. The KTA project has led on to the SEMIS project, which is a much more substantial project to try and deliver this technology into real use. And without the KTA, we would have been struggling to make the step from our previous research with Rapid Scan and Manchester Airport on security scanning of personnel to transfer this technology to landmine applications and UXO detection.
It's been a journey from why isn't there better equipment to why isn't there humanitarian equipment, through to certainly now we've got the backing of Aon and the risk management industry, through to a major UK charity dedicated to researching into developing better detection equipment, and in addition education programs for enabling people to live with the issue of landmines more safely prior to the demining occurring, and also providing medical care for those who have been affected by the problem directly.
In terms of where we're going to move suborbitally?
We are now in the position where we have worked really hard, and we are in a position where we're actually going to benefit. It's going to take a while, but hopefully not too long. And it's just crazy to think that, you know, the reasons why they exist. They don't deserve to exist, do they really?